Okay, hello everyone. Hello to the two of you. So, our next review is on rational functions. So, let's say this is paper 2. You could be asked to find the gradient of the tangent line at a given point. So, this is definitely can be solved using your GDC derivative at a point. So let's say your f of x is equal to, what was the example given a while ago? 5x minus 4 over x plus 5. So you simply encode this in your GDC and it will give you the derivative at a point that will be your f prime x. Let's say at x equals -1. Let's say for example that's the point given, so you will have it -1. So just encode this in your GDC. Okay, you can do that at your own time. So another question here is to graph, and if this is paper 1, you need to know that uh, after drawing the Cartesian plane, you can look for, so this is paper 1, you don't need a calculator, so you will not just copy it from your GDC. So the first thing you do is to find the vertical asymptote, which can be taken from the denominator equated to 0. So that will give you an equation. Remember, the answer is an equation, -5. And then your horizontal asymptote is getting the coefficient of the ratio between the numerator and denominator of the leading coefficients. So we have here y, horizontal is y, equals 5. Then after that, you draw the asymptotes. So -5, so let's say this is -5, and then here is 5. So you draw here, okay. And then you just choose one point. So you will, because there are many phases of rational equation, it could be like this, it could be this, it could be probably this, or it could be this one. So you already know the asymptotes. This is your vertical asymptote, horizontal asymptote, and this is your vertical asymptote. Then probably just need to test on the left side and right side of your, let's say, -5. So if we test x to be -4, for example, so what shall be the y of that? So where is our equation? So 5 times -4 minus 4 over -4 plus 5. -5 is -20, -24 over 1 is -24. So we have -4 and -24. So let's say -4, your answer will be somewhere here. So you know your graph is in this region. Okay, let's try -6. This is to the left of your -5. So we shall have 5 -6 minus 4 over -6 plus 5. That gives us, this is minus, no? Is it -4? Yeah. Okay, -30, -34 over -1 is 34. So we'll have a y on the positive region 34, so 6 somewhere here, so you know it's the drawing will be like that. Okay, that is plotting the points. So another thing that could be asked is, let me erase this. You could be asked to find the inverse, okay, inverse f, f to the negative 1 is actually the inverse of x. So this is again our equation, y equals 5x minus 4 over x plus 5. Now if you want to find the inverse, usually interchange y with x. So it will be x equals 5y minus 4 over y plus 5. See, we change all x to y and y to x. And then we can cross multiply this ratio. So x y plus 5x is equal to 5y minus 4. And then we put all y's together so we can isolate y. So if we put it there, then we'll have xy minus 5y, and we put 5x on the other side because we need all y's together. Okay, 5 negative 5x minus 4. Then here, as I do isolate, so we factor out y. That will be x minus 5 equal to negative 5x minus 4. So our y now is equal to negative 5x minus 4 over x minus 5. So this is our inverse of x, negative 5x minus 4 over x minus 5. And then you can be asked also to find the domain. So let me erase this part. Let's find the domain of this. So regarding f of x, the domain is, you can look at this, the domain is all x. So x is element of R except what? So for x, except negative 5, right? Because it's the asymptote. And then the range is all y's element of real except what? Except this part, right? Which is 5. Because it's the horizontal asymptote. It does not pass through it. Okay, so at some cases you can be asked to find, okay, from here, since you already have this one, you may be asked to find the equation of the normal. First, let's find the slope of tangent using your calculator. So, using your calculator, we go to calculus and then derivative at a point. The variable is x. The value is negative 1. That's the value of our x, first derivative. And then we just encode the function. We have, let me encode 5x minus 4 over x plus 5. So this gives me, oh, it's quite not so hard to solve. Anyway, 29 over 16. Therefore, the m of normal shall be equal to negative 16 over 29. But we need something. We need to find y. So let's find y of this. So let's substitute negative 1. So that will be 5 times negative 1. But if this problem requires this, then it could be in paper too. So let's just use calculator to solve for that. So that will be 5 times negative 1 minus 4 over negative 1 plus 5. And the answer is negative 9 over 4. Okay, so let me erase this. Now, to find the equation of the normal, that will be y minus y sub 1 equals m of normal x minus x sub 1. By the way, this one are your x sub 1 and y sub 1. Okay, so we have y minus minus, so that will be 9 fourths equals negative 16 over 29 x minus minus, so x plus 1. So this is already good thing for an equation. You don't have to express this into y equals mx plus b. You can have it in this form, y minus y sub 1 equals this form. You can have this form. It is accepted for SL students in IB to answer this way to find the equation. See, uh, in rational functions, we can ask a lot of questions. Okay, so we'll go to the next problem. Stand by for the next problem.